I think my processor is slow. Recording takes so much of time. Thank you, Kishore. Okay. Okay. Fine. So most of the topics, like here, we have actually seen it in first unit, but then we are going to just revisit a few topics here again. So for today's agenda, session, we'll just take what is a planning problem, and then what is a simple planning agent. We have already seen what is an agent. We're just going to add something called as planning agent. So what's the difference between the two? I'll let you know. And then what is a Block's world problem? Again, Block's world problem. We have already seen this in the first unit. Now we are just going to see it in terms of considering the Block's world problem, that is the strips problem, as a sequence of execution of the planning. Okay, so that is what is going to be covered in today's class. So what is a planning problem? It's nothing but you have the initial state given, and then you have the goal state also given. So you just have to find out the sequence of actions which you will be using which you'll be moving from your initial state to the final state. What is also involved is you will be having a set of operator descriptions, which means what, from one state to another state, how do you go, using what operator will you go. Okay, that is set of operators. Then, as I told you, initial state and then the goal state is also given. Now, you have to first of all compute a plan. Without a plan, if you just like that keep performing all the set of operations, then probably you'll not reach the goal state. So what is computation of a plan? It's nothing but what is the sequence in which the operators must be executed. That is what is called as calculating a plan. Okay, and once you have the plan with you, then you have to execute them in sense, from the initial state, what is your next state, what is your next state, then finally how have you reached the goal state. So this is what is called as computing or executing a plan of action. Then finally, your goals is nothing but it is specified as a conjunction of goals to be achieved. It can just be at location, that is one simple goal, or you can also have something like A and B and C, a sequence of conjunction of goals to be achieved. So it all depends on the problem what you're going to actually execute. Okay, so that is all about a planning problem. So what you must remember here is a planning problem will have an initial state and then a set of operations or a sequence of operations and the final state. So what is the sequence of actions you're going to perform? You have to decide. How do you decide? Depending on the plan of action. So that plan of action must be executed in order to reach the goal state. Okay, so the whole thing put together is called as your solution for your planning problem. Then planning agent. We have actually seen something called as a simple agent when we were discussing about the vacuum cleaner as one of the agents, right, in the first unit. Now, what is the planning agent? Similar to that, what is a simple agent? A simple agent, if you recall, it will be having perceptions, actions. Perceptions are nothing but all the inputs received from the environment. Actions are nothing but the sequence of actions which are given to the environment. And then planning is, earlier in the case you didn't have planning exactly in the case of a simple agent, but then when you call it as a planning agent, it involves reasoning about the actions that the agent intends to carry out, what actions must be performed. So that is what will be decided by the planning agent. Okay, but other than that, your perceptions, your actions, your environments and your constraints, all these are common for a agent and a planning agent. Okay, so what is constraints here? So the constraints, again, the set of conditions which you have to adhere to, right? So what are set of conditions when you have to adhere to? It can be hard constraints or it can be soft constraints. So when I say hard constraints, it must be achieved. You cannot skip the step. Okay, and when I say soft constraints, you may or may not follow that constraint. That is what is called as soft constraint, or you just call it as the set of preferences. So if you adhere to all these terminologies: perceptions, that is set of inputs received from the environment; actions, so those are the operations performed on the environment or given to the environment as an output; and planning involves how do you implement the agent to actually execute and work do the intended work, that is planning; and finally whether you have to adhere to the constraints or not, that is decided by the planning agent. So all these are just what is in planning agent. Next, another simple thing which says what is the difference between planning and problem solving. So planning and problem solving, if you take, so problem solving will have the states, actions, goal, and a plan. So when you take states, so the states are represented as data structures if you take a problem. If you take a planning agent, it's going to be in the form of logical sentences. Again, if you take the strips, so we have seen some strips actions. So there the actions are going to be preconditions, and the outcome of the operation is going to be called as post conditions. So here everything is going to be in the form of code, and there again you have to have a sequence of actions. So this is the difference between planning and problem solving. But in planning it is more powerful because of the representations and methods used. Now we are going to see different methods for planning. Say for example, starting from representation using strips method, then representation using hierarchical method, representation using first order logic, and then you have certain advanced planning strategies, say for example partial order planning and then full order planning. All these are advanced search strategies in case of planning that we will be studying. Okay, but whereas in the case of search methods that we have already seen, it just proceeds through the plan space rather than state space. I'll explain this statement when we solve a small problem. Okay, just remember you have something called as a search space, which is starting from initial state. How do you reach the goal state? When you go through a set of state spaces. Okay, so state space is nothing but different states. Say for example, you start with S0. So from S0 to reach to S5, let us assume, you can either go to S1, S2, S3, S4, S5, or you can go to S1, then parallelly you can go to S2 and S3. You will be having some kinds like that. So that is what is called as state space. So using that state space diagram, whatever logic you deploy in it to search through the state space to reach the goal node. So that would be considered when we solve a simple problem. But for now, just remember that you have something called as searching through the state space. Okay, to reach from the initial state to the goal state. That's all. And when I talk about sub goals, it's nothing but you can take a goal as such, or you can divide the goal into sub goal and independently try to solve each and every sub goal, right? So that the complexity is reduced. And once you get independent solutions to each and every sub goal, then combine all the solutions to give a final solution for the common goal. Literally, this is done only to break the complexity of the goal. So goals reduced into sub goals. Each sub goals are separately solved, and each sub goal is the sequence of action for each sub goal is then posted combined together to reach the total solution. So that is all about what is planning. Okay, then moving on to steps. Yeah. So then moving on to strips, this we have actually seen it earlier itself. What is STRIPS stands for? It stands for Stanford Research Institute Problem Solver. Okay, so usually we call it as three states: actions, and goals. And in some books, they would have called it as P. In some books, you would be referring to this as P, that is the set of predicates. I Okay, in most of the books we will be seeing it, seeing the strips as a four state set of conditions, which stands for PIOG: predicates, initial state, operators, and goal state. Okay, so the initial, this is how we'll be solving the problems as well. So what is P? The set of predicates. How are we going to express it? So here, if you see, at home, not, have bananas, all these are predicates. We have seen the first order logic predicates. So those predicate logic you have to use here. Then your I stands for initial state. Say for example, starting from one initial state, how do you reach the goal state? Okay, then based on some operators you have to, that is actions performed, you'll be moving from one state to another state. Okay, so that is what is given here. So in this, the other way of representing the same thing is a set of states. The states are input, I mean the initial state or the goal state, then set of actions and goals. Okay, so the other way to express strips language is states, actions, and goals. So what is states? So states, okay, so it is a conjunction of ground, function free, and positive literals. Okay, what does this mean? It's a conjunction of ground, function free, and positive literals. So if you ask me whether you have any negative literals here, no. Then function free, what is meant by function free? Say for examples, have banana. If I have something like have of x, okay, then that is that have is a function, and that function is a function has a variable x, so it's dependent on the variable x, so that is not allowed in the case of strips. Okay, so it should be function free and it should be ground. So if you have all these conditions to be satisfied for any given literal, in that case you can call that particular state as a state, or that particular FOL, first order logic, as a state. Okay, then moving on to goals. So you have the initial state and then you have the final state. And what is a goal? Goal again can be conjunction of literals. Okay, may contain variables. So may contain variables in sense this x and all can be there if it is a goal state, and it can be a their existential quantifier can also be there. So goal state can be represented as more than one state. So all these are possible. These are just the things that you have to know before we move inside. Okay, and actions is once your preconditions are true, that has to be executed, and effects after the execution. And if your preconditions are true only, then you can go to the execution mode. Okay, say for example, if I just say I want coffee now. Okay, so now I want coffee. Okay, leave that word now. I want coffee. I'm asking you, which means what? The preconditions must be I am hungry, so I want coffee. So that preconditions, if and only if that is satisfied, what would be the action now? Action will be serve coffee. So once serve coffee is executed, then the post condition, the goal is satisfied. What is the goal now? Goal is nothing but I am not hungry, or I had coffee. So whatever you want, you can put. So here the first order logic predicate, I can put it as I am not hungry and I had coffee. So this is how you have to express. So here, whatever is given here are some of the examples. So at home and does not have banana, which means what? One goal is initially you had bananas at home. Okay, but now you don't have bananas at home, which means what? You have sold to someone the bananas. Okay, so the bananas, it's no longer there in your house and it has been sold to someone else. So here the action is what? Sell bananas. Okay, so this is how you have to move from one state to another state. Normal first order logic you have to write, and then add to it the preconditions and post conditions. Okay, now moving on to another example of strips, the usual common example, which is nothing but your, what problem is this? Block world problem, right? So now how do you write? This is only important. So your goal state is on A comma B. This is the strips way of writing it. Okay, so on A, that is A is on B. That is what is given here. Probably you can add one more goal state saying and clear of A, which means nothing is on top of A. Okay, what is the start state here? So start state says A is on table, B is on table, empty top, okay, we call it as clear A, right? So the same thing, they have given it as empty top A, empty top B. So which means clear A, clear B. Okay, so now if you add the operators, what is the operator? Move x comma y. So x comma y here are replaced by A and B. Move A comma B, right? So here just replace the preconditions and give me the answer. So precondition is x on table, comma, empty top of y. And this is just the representation of strips, but then this is not the strips action for this particular start state to goal state. Okay, don't get confused over that. So you had add list on x comma y. So this is the representation of writing x is on y. Precondition x is on table, empty top of y means this can be, you don't have anything on top of y. So this is how you're just writing it. Okay, and delete list empty top on y. So because on top of y you have now a, that is x. So on x comma table. So all these are the preconditions, actions and post conditions. I'll give you one more example because here you might be confused because x and y are not represented, but then just to understand what is strips way of writing it, this has been given to you. Okay, now just right, I want you all to answer this, the basic planning algorithm. Okay, see, for example, you want to be an author or co-author for an AI research paper, okay, with both theorems and experiments within 1 year. Okay, so to achieve this, what would be the preconditions and how do you what would be the goal of doing it? Okay, so the goal here is you have a research paper with you and it has been contributed by you. Okay, now very simple, how do you write this? Simply you have to put preconditions and post conditions, that's all. And whatever is given on top in the bold is nothing but your actions performed. Okay, so what you have to do is write in simple English whatever you know. Simply if you just say that precondition is has time for study, I have enough time for study, x has enough time for study. If this is my precondition, then my action is what? Learn about. So that is my function, x learns about y. So x is learning something about artificial intelligence. So that is my action. What is the post condition? Post condition is now x knows y, x knows about artificial intelligence, and now he does not have time to study x. Okay, he knows this and probably he's studying something else. Okay, so no more he has time to study x. So that is what this means is. Very simple. So right from the first step to the last step, so what are all the things you can think, you can just put it as actions. Okay, so those are called as planning sequences. So what is planning sequences here? X is learning about artificial intelligence, so that is first one. Next step is what? Now x has a new idea. Okay, so some new idea you have. Then find existing open problem. So x is trying to find a existing open problem. Okay, so either of these conditions must be true but not both. If you have your own new idea, you can implement it, or if you want to find a research problem, that can also be done. Find existing open problem. Then what should you do? You have to prove the theorems, because here they say you have to prove the theorems and experiments. So prove theorems is one action. Then perform the experiments, that is the next action. So once you're ready with your results, then what you should do, you have to write paper. So this is going to be your sequence of actions to reach your goal, that you finish your paper and the contribution was done only by you. Okay, so to achieve all these actions, now what should you do next? So you have learn about x comma y as one of your actions. So what is the preconditions and post conditions that you can fit inside? So that you have to add. Okay, So I just leave all this imagination to you only. Based on your English assumption, you can think of it and write it in sentence. And then what you should do is you have to convert it into a first order logic or a predicate logic, and then you have to write here. Okay. Now what does this have new idea of X? To implement this action, have new idea of X, what should be the precondition? Precondition is you must know AI, okay, and you should be creative. So if these preconditions are satisfied, and if you implement have new idea of X, so you're implementing a new idea, then what would be the post condition? Idea has been implemented and it has been contributed by X. So this is what is going to be the post condition. Similar to what I told you earlier. So for each and every action, have coffee was my action. So having coffee, before that, what is the precondition? I was hungry, I didn't have coffee. What is the post condition? Now I'm not hungry, I had coffee. That's all you have to put. Very simple, right? Then coming to the next action here. What is the next action? Find existing open problem. So when I say find existing open problem, precondition is I should know something on AI. Only then I can find some problem on artificial intelligence, research problem. Then what is the effect? Effect is going to be idea, or you can just put that contribute of X. Okay, so this is also done. Similarly, prove theorems of X. So to prove theorem, what is that? You have to know AI, you have to know math in AI, and then you should have an idea. So when I put commas, we have already seen that in the predicate logic, if I just put comma, comma within curly braces, okay, then it means it is conjunction of literals. Okay, so all these are conjunctions. So I know AI, I know math of AI, and then I have an idea. So the after I say action as proof theorems of X, the effect is going to be theorems has been contributed by X. That's all. Similarly, performs experiment. To perform the experiment, what should I know? I should know AI, I should know math, I should know coding. That is one more thing. Okay, and I should have an idea. So if I have all these things only, finally I'm going to perform the experiment and contribute to X. Right? Finally, to write the paper. To write a paper, I should know AI, I should know how to write a research paper, I should have idea, I should have written the theorems or proof theorems, I should have done the experiments. So if all this is done, the finally after writing paper, the post condition is going to be paper is contributed by X. Okay, so this is what about planning. So what is planning? In simple statement, from initial state you have to reach the goal state. How we are going to reach the goal state? In step by step sequence you have to mention that step by step how do you progress. That is by means of actions performed. So your actions performed are usually put on top as actions, and for an action to be performed, you'll be having a set of preconditions which has to be satisfied. And after the action is performed, you will be listing out the set of post conditions, or it is also called as effects. So that set of post conditions should also be written. Okay, so this is what is in nutshell planning all about. Then coming to the block world problem. Okay, now how do you represent some start states? Probably you can choose your start state as anything. Okay, any one of these four states can be your start state. As I told you, I'm not going to check whether you're perfectly writing. I just want to know whether you have some idea of what is trips. Okay, so you can start with anything. It can be your own imagination. Okay, one of you will write, I have time to study. Okay, and I know math, and I know coding, and I know to write. So this may be your start state. The other person will come and say that, okay, you have time to, I have time to study, I am creative, I have an advisor for AI, and I know I have an advisor for mathematics in AI, and I have an advisor to teach me coding, and advisor knows how to write a paper. So if this can also be taken into consideration as your start state. There is no concrete way of planning. So each one will have their own planning methodology. Only thing, you have to put the start, whatever states you're, whatever assumptions you're making, that has to be properly put in the paper as called as preconditions for a particular state. Okay. So similarly, start 3 and start 4, again you can represent different types of the same thing. For what are you representing all these start state? To achieve the goal state that you're going to come up with a research paper in AI. Okay. So if you know all these things, probably after performing the exercise, the experiments, you will be coding it, implementing it, and then you'll be writing your research paper. Okay. Now coming to state of the world. Same thing, it's again repeated. Okay, what is the state? As already mentioned in STRIPS language, it's going to be, it should be positive, it should be function free, and it should be ground. Okay, so what does that mean here? Okay, if you have a dot symbol, then that is not ground, that is not positive, right? If you have an X symbol, then that is not ground. It should be specific. At room or at bedroom, it should be specific. It cannot be X, and X cannot be assumed. Okay. Then the third one is, it should be function free literal, which means one, I cannot just like that say bedroom of X or home of X. In home, X can be any room, kitchen, whatever it is. Okay. So I should be definitely saying that it should be specific. Okay, so here function bedroom is used, so it should be function free literal. Okay, so I cannot put bedroom of X. So that is what is the condition for a state representation in STRIPS language. Okay, now if you just come here and check at home, and is that umbrella is at home and can be carried of umbrella, and umbrella is umbrella of umbrella. Okay, you're passing umbrella as an object, and the boolean that is going to be returned is true. Okay, and hand empty and dry. Okay, perfect. So this is a typical example of a state, right? So you have only positive literals, you don't have any function that is ground. Okay, which means just like that saying at X, nothing of that kind. And you don't have any functions. You have functions, of course. Is at this particular, is at umbrella, is at home is a function, but then the function is free of literals, which means what? You don't have something saying umbrella is at X. So you should not have a function of that kind. So if all the three things are satisfied, then that you call it as a state of the world. Got it? So we can see some more examples, whether to find out whether the given first order logic, the expression is a state or not a state as far as the STRIPS language is concerned. Okay, this is only for STRIPS, don't get confused. Okay. Okay, next moving on, what is an object? So now we have just seen what is a state. Now we are going to see what is an object, right? So when I say object, again, what should be done? You should have preconditions. Then you're going to have an action. Based on the action, you have to write down the post condition. Post condition means the effect. Okay. So here, let us just see. You have the action given as take object from location. Okay, take the object X at location. Okay. So if this is the action performed, what is the precondition? Your hand is empty. This can be carried, probably a pen. Okay, so at location. So this is a pen is at some location. So these are the preconditions. Okay. Now, what is the effect? Effect is, okay, you don't have take object has been done. So at location, okay, this is not at location, right? Which is not at location. The object, whatever you're mentioning, is not at that particular location. Okay, so you're holding that object, not hand empty, because here you have already put hand empty. So now you are holding something. So your hand is not empty, and not of this particular location. That pen is not at that location. Okay. So these are going to be your post conditions. Got it? So this is how you represent an action. And finally, a goal and a plan. Okay. So what is a goal and a plan? Goal here is how do you reach to this place? So you have to go to work and you have to be dry. This is your goal. Okay. Initially, you are at home and you have an umbrella at home, and an umbrella can be carried. And umbrella is an umbrella. This is actually not required. Your hand is empty and the climate is dry. Okay. So after this initial state, what is your take object? So okay, your action performed is take the object. Okay. So you have the umbrella which you're taking it, take the object from your home. So at home it can be carried, umbrella is umbrella, and you're holding the umbrella is the current state. So initially your hand was empty, now you're holding the umbrella, then you're going to walk with umbrella. That is your next action. So you're taking the object is one action, you're walking with umbrella is another action. Where you're walking from home to work, you're going to walk with umbrella. So for that again, you're at work and you have an umbrella. Umbrella is an umbrella and it is dry and you're holding the umbrella, which means you're just walking with the help of your umbrella from home to work. This is the action performed. Okay. Initially you are at home and now after this action was performed, now you are at work. That is the only difference. All the rest is the same. Okay. So now what is the goal state? Now you are at work and you are dry. So at work and you are dry. Where is that dry? Yeah, and dry here. So these two conditions has been met. So using the sequence of planning, what is the sequence of planning? Taking the object, walking with umbrella. So using these two steps, you have reached from home to your workplace and you are still dry. So your goal is achieved. Okay. So this is how you just have to write down. So what is precondition? To do this action, take the object, your precondition is the state. Okay. Now to walk with umbrella, to perform this action, okay, your precondition is this particular state. You have to be in this state and you can walk with umbrella. This is going to be your action, as a result of which your post condition is going to be the final output, whatever you have got here. Okay. So this is what you have to remember. So far, nothing we have done, only one simple logic has been explained. Just whatever the situation is given to you, think it in terms of simple English, then write down the sequence of actions to be performed in English. Then convert it into the predicate logic. Okay. So for each and every action that you're going to convert, the action should have a precondition and it should also have a post condition. Okay. So from a precondition, after the action is performed, what happens is going to be the post condition. That has to be illustrated. Got it? So that is all about your simple planning using strips. Now moving on to the next important topic, that is nothing but using strips. How do you solve the block wall problem? Okay, what is block wall problem? I'll come back to this after I finish the next slide actually. Okay, what is a block wall problem? You have the initial state given and you have the goal state given. How do you move on from your initial state to the goal state? So that has to be done. Okay, so to do this, what is the sequence of operations? Now your initial state, using your predicate logic, how is it going to be represented? Initially, you have on table A, that is A is on table, D is on A, okay, C is on D, B is on table, and on top of B you don't have anything, which means clear B, and on top of C you don't have anything, clear C, and the robo arm is empty. So these are the initial states. So here I have given it very clearly in the form of predicate sentences. Okay, and the goal state is, here you have B on table, D on B, A on D, clear A, clear C, C on table, and robo arm is empty, hand empty. Okay, so to go from here to this state, now quickly tell me what are all the steps that can be followed. Okay, so the first step, unstack C and D. So you're going to remove this. So unstack C and D, put down C. Okay, then unstack D and A, put down. Okay, once you unstack means what? Stack D, take this D and put it on top of B. Okay, because here you have B, then D. So you just take this and put it on top of D. Okay, then A is lying on the table now. Pick up A and stack A on D. That's all, right? See, you have already put it down, so that is still down. So your goal state is actually reached. So you have actually, using these actions from your initial state, you have reached your goal state. That's all. Okay, so what is this unstack all these actions? Now we have to see. Okay, that is going to be your objective for the class. So again, I repeat, your initial state is given and you have to reach your goal state. Okay, so first step, what you'll do, you'll pick up, you'll actually remove C. So unstack C and D because these are on stack, and place C down. Okay, once you place C down, that is actually your goal that is achieved. Then unstack A and D. Okay, so you're removing D and you're going to put it on top of B, which is stacking B and D together. Okay, so that is stack step. Then what you should do, pick up A and put it on top of stack A and D together because already you have D here. So on top of D, you're going to put A, which means stack A and D together. So these are the sequence of operations you have to perform. Got it? Now I'll go back and I'll explain how this has to be done. Okay, what is this step called? Pickup. These are the actions which are written on top. Pickup is an action, put down is an action, stack is an action, unstack is an action. As you can observe from here, all the actions, unstack, put down, stack, pickup. So 4 actions you actually have. Okay, so for all the 4 actions, you have to just write what is the precondition and what is that you have to delete and what is that you have to add. Okay, so once you add these 2, in that case, your pickup function is done. Okay, so when I say pick up X, which means what? You can pick up an object if and only if that object doesn't have anything on top of it. So the first precondition here is it should be clear of X. Okay, on table of X. So this may be true or may not be true. Even on top of stack, you can pick up the object. Okay, then your hand is empty. So these are the preconditions. Okay, then what is the delete list? So you're going to pick up the X. So clear X you have to delete. Then on table of X you're going to delete. Hand empty you're going to delete. Pick up X means you're going to hold the object in your hand or in the robo hand. So hold X, which means that has to be added to the conditions. Got it? So this is how you expand a particular function. Then when I say put down, you're holding something, right? That should be your precondition. Only then you can put it down. So no more you're going to hold something, so that you have to delete it. When you put down something, what happens? It is lying on the table. So your on table is there, your hand is empty, and on top of that, you don't have anything. Okay, so that, which means clear of X. That is what is called as put down of X. Then coming to stack X on Y, which means what? You're going to put X on top of Y. Okay, so very simple. We know how to write it. Just like that, if you just use this function, X on Y, this last function, that is going to work out. Okay, but then how do you explain it in the STRIPS logic? You should have a precondition. What is precondition? You're holding X and on top of Y, you don't have anything. Okay, only then you can put X on Y. If you have on top of Y something, you cannot stack X on Y. Okay, so then what is going to be there? You're going to put it down. stack x, which means put x on top of y. So you're going to say you're no longer going to hold x, so that will be removed. And clear y, because you're dropping x on y, clear y will also be deleted. Now what is going to be added? Since x is on y, on top of x nothing is there, so clear x on x comma y. That is the function that has been added, right? Once you have dropped it, your hand is now empty. So that is going to be your stack of x comma y. The same thing, unstack x comma y, which means what? From x and y being put together, you're going to remove x from y. Okay, so if you're removing x from y, what happens? So here again, only one operation that you have to do is, in the delete operation, you're going to have x on y must be removed. Okay, so then your hand is going to be empty once you unstack it, right? So this is just the preconditions and post conditions for each and every action that you have to write for a given block wall problem. This will never change. Got it? But then how do you represent when a problem is given to you? That is most important. Okay, I will go to a problem. This is your problem. Your initial state is given, your goal state is given. How do you move on from your initial state to the goal state? Okay, so if you just check this, first your initial state is written here. What is your initial state? On table A, on table B. B, you don't have anything on top, clear B, clear C. Okay, so D is on A and C is on D, right? So all these are your preconditions. Now, once you have a precondition, what is your action? Action, first action, what did we see? Unstack C and D. So you have to remove these two. Okay, unstack C and D. That is my first action. Okay, unstack C and D. So once you unstack, what happens? On table A. So A is still on table. B is still on table. Then D on A is still there. Okay, but C on D should be deleted. That is what we saw it as delete list, right? And clear C must be deleted because no more C is clear. Or it may be true, I don't know. But now, as of now, clear C must be deleted. And since you're unstacking, which means using the robo arm only, you're picking up C from D. So your robo arm is not empty. Hand empty is deleted. Now, what are the actions that has to be added to the list? Holds C. What holds C? The robo arm is holding C. Okay, and D, there's nothing on top of D, which means clear D. So these are the two predicates that has to be added to the list. So once you have a precondition list, what you have to do is perform the action. What is the action performed? Unstack C comma D. So once the action is performed, what happens here is you will be removing certain things and you'll be adding certain predicates. So what is that removed predicates here? Whatever was there in the list already, only from that list you can remove whatever that has to be removed. And you can add a few more predicates. Okay, so unstack C comma D is done. Now what should you do next? You have to put down C. Put down C means where are you putting it down? You're going to put it down on the table. Okay, so now when you put it on the table, what is that you expect? You expect on table A, that's right, on table B, on table C is added to the list because C is put on the table. Okay, hand empty, right? And what is that you have to delete? You just have to delete hold C because no more your robo arm is holding the C. Okay, so just like that you're dropping it down. So that is all about the put down C. Then coming to the next operation, the next sequence, unstack D and A. So here you have to remove these two. Okay, remove these two is one step. Then put D on top of B is the next step. So when I say unstack D comma A, what should you do? The same story again. So on table, here on table, yeah, D on A. This step can no longer be valid. So I just have to delete it. Okay. Then clear D, again I have to delete it because I don't know whether I'm going to put it down or what I'm going to do with it. Then what are the things I have to add? robo arm is holding D and clear A. A doesn't have anything on top of it, right? So clear A has been added to it. Then what are you supposed to do now? Put this D on top of B. So when I put D on top of B, what happens? Clear B must be deleted. Okay. And holding D must also be deleted because you're not going to hold it anymore because you have dropped it. And what else you have to add? You have to add clear D, which means on top of D, nothing is there. Okay. So those things you have to add it here. That is stacking D on top of B. So this step is done. Okay. Next, what you should do, pick up A. So you have A here. The finally only one block which is left, which is A. Pick up A, you are going to do, and you have to put it on top of stack A on top of D. That is the last step. Okay. So pick up A means what? Now you have to say that hold, you cannot say hand empty. You have to say hold of A. Okay. And clear A can be deleted. Hand empty must be deleted. And on table A must be deleted because A is not on table now. It is with your robo arm. Got it? So once that is done, then your next step is to stack A on top of D. So you just have to insert one thing which says stack A on D, this particular predicate on A comma D. And your hand is now empty and you have to remove hold of A. Okay. So at each step, just remember whatever preconditions you had earlier, from those preconditions, you have to delete a few predicates. And after this operation is performed, you have to add a few predicates. That is what is called as delete list and add list. Okay, moving back. Here I have mentioned something called as delete list, add list from the preconditions. Okay, so delete list is nothing but from whatever precondition. So this becomes your precondition for unstack C comma D. So here you have to delete a few predicates and after performing this operation and add a few predicates, right? So this sequence, like starting from here, first column, then unstack D comma A, unstack D comma B, then pick up A, stack A comma D. If you do like this, right, what is actually, while you're writing in paper, we will expect each and every action to have precondition, postcondition. Then again, when I ask you to write down, put down C, you have to write down this as precondition and this as postcondition. But that's okay if you just mark it as precondition, I mean, first preconditions, strike it out with pencil or, I mean, another color pen, showing that these are delete list, or you just write it as delete list. And whatever is inserted new, you can add it as new list or added list. Okay. Or with a different color pen. That's it. So this is an important question for a block wall problem. Okay, how do you show the plan of execution from initial state to the final state? That's it. So using strips, that is very important. Okay, and finally a few to do problems using strip. So just tell me how this can be done, and this would be your homework, which means from this initial state you have to go to the goal state. You have to show me the plan of execution. Okay, now quickly tell me, how do we solve this problem? Since I started only, I have been talking, just 5 more minutes we have. I want any one of you to answer how will you represent the precondition, action and post condition for the given problem. So what does it say is, show the action of Rob. Okay, Rob means robo. Okay, robo to pick up coffee at the coffee shop using strips representation. So quickly tell me, how can I do it? So action is what? Robo pick up coffee. So this is my action. What is my precondition? And what is my post condition? I want to hear at least 1 or 2 answers. Robo pick up coffee at the coffee shop. Okay. Can someone give me an answer, please? 145. At least in the message, see, all OD numbers and all correctly I'll get. But only answers I don't get. Quickly, guys. I have to go for another meeting now. Precondition is what? Robo is picking up coffee. So what can be the precondition? I told you this is all your imagination, nothing more. No answer, no attendance for today's class for all. Very simple question I've asked. Come on, please. Don't stay like this. What would be the precondition?
Preparing the coffee, I guess. I mean, coffee should be. Not sure.
There should be a
Should,
cup of
will
coffee
the
ready.
robot is picking up the coffee?
There should be a cup of coffee ready.
Coffee ready. Okay. Right then. And anything else?
The robo is at the
Make sure
coffee
we-
shop.
Yeah.
Yeah,
Robo should be
right.
to coffee shop.
And Sam should want it, right? There should be an order or something.
Okay. So this is your precondition. Then post condition. Robo is at coffee shop and coffee ready. Coffee ready is just a literal. Don't make it as a function. Okay. Coffee ready. Then post condition is Robo has picked it up. Okay. Pick up coffee is a action. Post condition, after it has picked up coffee,
It will reach the destination.
it's not going somewhere. It has just picked up the coffee. So what should it be? It can only be one state transition at a time. Don't imagine a long way and then say that Robo picked up the coffee, went to the person and it has served the coffee. No. So this is just one single step. Pick up coffee. So what would be the immediate condition? Coffee ready and Robo is that coffee shop. Okay. So pick up coffee. So here actually you can put one more statement saying that not pick up coffee. So if I put not pick up coffee, so coffee is still not picked up, but then the coffee is ready. So it simply means has coffee, correct? Can this be the case? So once it has picked
Yes,
up,
ma'am, yes, ma'am, right.
yeah, or you can here put it as hand empty. We cannot have a negative clause, so we'll just put it as hand empty. Okay. Then it has coffee. That's it. Because the action here is pick up coffee. Very simple. So you should just keep in mind that the state is going to be only one state, not thinking beyond. Okay. Now, if you want to negate, you cannot say simply, you cannot delete coffee ready, and you cannot say that robots at coffee shop can be deleted. No, post condition still holds good, but then only one thing has been added to the list. Okay, instead of hand empty, only that has been deleted, and the other entry that has been added is has coffee. Okay, so this is the added, this is the deleted entry, and has coffee is the entry that has been added to the list. Got it? That's all. Now, coming to the next action. What is the next action all about? The action of delivering coffee to Sam, who wants coffee. Okay. So what would be the precondition? Okay. So the precondition is going to be coffee ready and Robo is at coffee shop. Whatever the post condition was already given. So that becomes your precondition for this step. Okay. And the action here is already given. Deliver coffee to Sam. Okay. So this is the action for which is actually given in the problem. Now what is the post condition? Post condition is going to be, post condition is, now look into the precondition and give me the post condition. Should I put coffee ready? Robo at coffee shop has coffee. what should you delete and what should you add? That's all. That's my simple question. Only from your precondition, you can come to your postcondition, right? So precondition says coffee ready and Robo is at coffee shop and it has coffee. So you have 3 different clauses, 3 different lists. You can just have it as 3 different lists. So your post condition, coffee ready, will it be there? Or should I delete it? In your post condition, after this condition is delivering coffee to Sam. Yeah, right. So you have to delete it. So coffee ready, it has to be deleted. Robo at coffee shop, can I have it?
Yes, ma'am.
Yes, you can have. Good. And has coffee, again, I have to delete it. Okay. Because it has been delivered to Sam. Now, what other post condition can I add? Probably I can add not of Sam hungry. If I'm adding this, probably what should be the case? Precondition, I should have introduced something saying that no, has coffee, right? Has coffee. Who has coffee? Sam. Okay, if in my precondition I had a condition saying Sam was hungry, then I can change it as not Sam is hungry. Okay, but now I didn't have any such precondition. So precondition, okay, action deliver coffee to Sam. So probably I can have the precondition as hungry of Sam. If I have this as a precondition, then in my post condition I can add not hungry of Sam. That's all. Got it? Because in my action I had this terminology saying that Sam is, delivery coffee of Sam. So I've introduced one precondition here, and that precondition I've just negated as a post condition. That's all. Okay. So just remember one thing: for each and every state, there can be only a set of preconditions and a set of post conditions. Okay. And to the set of preconditions, you have to delete a few conditions from the list, and you have to delete a few conditions. You have to add a few conditions so that you get the post condition after the action has been performed. Got it? So this is all you have to do. And now the same problem, like what was already done. So the same problem, I have just put the initial state and final state. I have just interchanged these two. Okay. So what I wanted to do is figure out the planning sequence, and for all the planning sequence, this problem has to be completed. So this is actually one big question. Okay. How do you move from initial state to the goal state? The planning sequence, this is your planning sequence. How do you do the planning sequence? By adding and deleting to the list. This has to be executed and shown. Got it? So I want you all to do this particular problem. So I'll post this in your GCR. Okay. So for today's class, I think this is enough. We'll continue with it next class. Thank you.
Thank you.
Thank you comes very fast.